This is a copy of the periodic table that we've seen before, but I'd like to talk about some different features of it this time. We'll notice that in the column to the far right-hand side, we have elements hydrogen, neon, and argon. These elements are referred to as noble gases, the idea of noble inferring nobility or set apart. And from a chemistry perspective, these particular elements are very stable, meaning they don't have a desire to react easily with other elements. So a logical question would be, why are they so stable? And the answer has to do with the numbers of electrons that they have. There's something special about having 2, 10, or 18 electrons. Now what's special is that with this number of electrons, the particular orbits around the atom are full of electrons, and being full with electrons provides special stability. So what other atoms on the periodic table want to do is try to achieve this number of electrons associated with the noble gases. Now, it's important to remember that when an atom gains or loses electrons, that has not changed the atomic number. You only change the atomic number by changing the number of protons. So when I say these other elements want to have the special number of electrons associated with the noble gases, I do not mean they will turn into the noble gases. They will have the same number of electrons, which relates to this idea of special stability. Now, how these other elements can get this number of electrons, we'll talk about in a little more detail, but I'd like to mention it now at least to you, and that is the idea of bonding. These other elements can share electrons, which is a type of bond called covalent bond, or they can transfer electrons by either loss or gain, and that type of bond is called an ionic bond. So, for example, if we look at carbon, carbon has two options with respect to electrons. It could gain electrons, or it could lose electrons. Now what will typically happen is carbon will gain the electrons. Now let's look at some more extreme examples just to make our point on the table. If we look at sodium, sodium has an atomic number of 11, which means that it has 11 electrons associated with it. The special numbers that bracket that are 10 and 18. So sodium has two options. It can either gain 1, 2, 3, 4, 5, 6, 7 electrons to have 18 total, or the sodium could lose 1 electron so that it had 10 electrons. Again, both of those numbers being associated with special stability. It's easier for the sodium atom to lose an electron than it is to gain 7 electrons. So sodium will lose an electron. If sodium loses an electron, but the number of protons remains the same, then the charge is no longer 0. So because the sodium that has lost an electron will have 1 additional proton, in other words, it will have 11 protons and 10 electrons, then that form of sodium is referred to as the sodium ion, or Na with a +1 superscript. Another extreme on the periodic table would be chlorine. Chlorine has an atomic number of 17, which means it has 17 electrons. Again, the two elements associated with special stability that bracket it are argon, which has 18, and neon, which has 10 electrons. So chlorine has two options. Chlorine can either gain 1 electron, or it can lose 7 electrons. Now it's easier for the chlorine to gain the 1 electron. So chlorine will now have 18 electrons associated with it. It still has 17 protons though. So that means the chlorine ion will have a -1 charge associated with it. Now we've simply focused on the extremes of the periodic table, things that were all the way to the right or things that were all the way to the left. The question might be, well, how do you predict if other elements will gain or lose electrons, or if they'll share electrons? And the answer has to do with something called electronegativity. And for those of you going on to chemistry, you'll study electronegativity in more detail. But basically, electronegativity describes an atom's desire to gain electrons. Elements on this side of the periodic table tend to have high electronegativities, meaning they have a high desire to gain electrons. So elements on this side of the table will form negative ions because they are gaining electrons. Elements on this side of the periodic table tend to have very low electronegativity values, meaning they would rather give up electrons than try to gain electrons. So these elements will tend to have positive values. For example, Na plus 1, or K plus 1, or Li plus 1. Now, we won't be working with electronegativity differences in this class, but I would like, for those of you going on to chemistry, to at least have heard of this idea because it will be a crucial one to you in your further studies of chemistry.